Hi, welcome back. In this lecture, I want to finish up the series of lecture related to the mathematics for quantum computing. And I want to deal with a very interesting topic that is entangled vectors. You probably heard about the curious effects of entanglement in quantum computing. It might surprise you that entanglement is actually a concept that is coming from math, right? So it's very nice to look at the details of the math in this particular lecture to see the connection that we are going to have later between the math and describing the entanglement. So the topic is entangled vectors. So let's see the definition of entangled vectors that comes up by this basic question. So given a vector, for instance of this structure, can we write this vector as a tensor product of two vectors? Remember that the tensor product is easily defined in this way. So if you have two vectors, one with the elements x and y, the other one a, b, c, the tensor product between the two vectors is basically the first element multiplied by all the second element, and then the second element of the first vector multiplied by the second vector. So we have going to have these two parts. So I have a small problem for you. Can you devise two vectors whose tensor product results in this vector here? I give you a few seconds to think about it. Well, yes, we can actually write these two vectors. So the first one, for instance, we can write it as 2 and 3. And then we have the tensor product. And then we have a second vector that is going to be 4, 6, and 3. So let me verify very quick that I didn't do any mistake. So this is going to be 2 multiplied by all this. So 8, 12, and 6, that is corresponding to this. And then we have a 3, 12, 18, and 9. So yes, is actually we can express this vector as a tensor product of the two vectors. That also means that we have two quantum systems. Then we can combine this, and this vector that is the combination using the tensor product is the combination of two simpler quantum states. Let's look at another example. The question again I have for you is, can we write this vector as a tensor product of two vectors? Well, we can think a little bit of time, and the answer is actually no. We cannot really express this vector as the tensor vector of two simpler vectors. So no matter what we try to do, we will never be able to express this vector as a combination of the tensor product of two vectors. So there are no real solution that will give us the required results, unfortunately. So this leads us to the definition of separable and entangled vectors. The first example that we saw is the following. So we managed to find the two vectors to combine in one big vectors, and this is called separable. So we call a vector that can be written as the tensor product of two vectors separable, and this is the first case. On the other hand, in contrast, a vector that cannot be written as a tensor product of two vectors but can be written as non-trivial sum of such a tensor, for instance, is called entangled. So we will see in our lecture later on, when we're going to talk about entanglement in quantum circuit, this specific vector, and we're going to talk about entanglement and entangled vector. So it's very nice to see how the math exists before the physics, and how advanced concept math can express some difficult concept that we are going to find later on in quantum mechanics, in quantum computing, called entanglement. This is the last slides of my lecture, and talk to you soon. And we're going to look at a few more interesting topics in quantum computing. Talk to you soon.